Mr. Repke here. We're still talking about complex fractions, but we're going to add variables. So let's do a complex fraction with some letters. As you can see, there's not much to do at the top, x minus 1. The bottom, we need common denominators, and our common denominator would be the letter x. Adjust my numerators. 1, the number 1 becomes just x over x. My second fraction doesn't need to change. Simplify the bottom, and that gives me x minus 1 all over x. And again, we change this to a multiply problem with a reciprocal. So the bottom fraction flips. And we can put this over 1 if we need it. Oh, look, my x minus 1s, because it's the entire thing, are allowed to cancel. So I just get x over 1 or just x. Another example with letters. Let's do x over 2 plus 2 over x all over x plus 2 over 2x. Like our other fractions, we have a choice. We could find the least common denominator or least common multiple for all three fractions and multiply everything by that, or we can keep the top and the bottom separate. And in general, I'm going to try to keep the top and bottom separate. So for the top, my common denominator would be 2x. How do I do that? Well, I multiply the first fraction by an x. X times x, it gives me x squared for a numerator. And how did I change the second fraction? Well, I multiplied it by 2. 2 times 2 is 4. And on the bottom, there's nothing to change because it's only one fraction. Add the top, that gives me x squared plus 4 over 2x. My denominator is x plus 2 over 2x. Change that to a reciprocal and multiply. And we see, oops, I'm sorry about that. We see my 2x's reduce, and I'm just left with x squared plus 4 on top and x plus 2 on the bottom. And that does not reduce because x squared plus 4 does not factor. What if we did it the other way? Well, the least common multiple of 2x and 2x is 2x. I would take all three fractions times that 2x, x times 2, x divided by 2, times 2x. My 2's cancel. There's where my x squared comes from. 2 over x times my least common multiple of 2x. My x's cancel. 2 times 2 is 4. And on the bottom, x plus 2 over 2x times 2x. Those entire 2x's cancel, which just leaves me with x plus 2. Again, the method that you use doesn't matter to me. It's which one works best for you. What if we have two letters? What if we do x plus x over y divided by 1 plus 1 over y? Well, you might notice that doing it either way actually is the same way because we only have a denominator of y. So why don't we do just the least common multiple way and multiply everything by our least common multiple of y. So that means x times y, which is just xy. That means x over y times y. Y's cancel. That leaves me with an x. On the bottom, 1 times y, well, that's just y. And 1 over y times y, that's just 1. And we're looking at this and we say, well, we think we're done. It looks like we're done. Is there anything I can do? Well, what if I factor GCF and x out of the top? Now I notice my y plus 1's cancel. So my answer is just x. And that actually wasn't too bad. Let's try another one with two variables. 1 over x minus 1 over y, all over 1 over x plus 1 over y. We need common denominators. And again, if we look, we notice that my least common multiple, what's the easiest way to get a common denominator? If we multiply the two denominators together. So that is just xy. So let me take all four fractions and multiply them by xy. 1 over x, that's cancel and just leave me with a y. 1 over y times xy. The y's cancel, that leaves me with just an x. On the bottom, I would have y plus x. And this doesn't reduce because it's adding and subtracting, so there's our final answer. That one was actually very quick. Let's do another one. 1 plus 1 over x minus 1 all over 1 plus 1 over x squared minus 1. How we do it is up to you. I'll do it both ways. I will say here, let's remember though, side note, x squared minus 1 is x plus 1, x minus 1. We should remember to factor that as difference of squares. So if you keep them separated, we know that on the top, our common denominator needs to be x minus 1. That would make my numerator x minus 1. That would stay the same. So that just gives me x over x minus 1. In the bottom, my common denominator would have to be x squared minus 1. So that changes the numerator to x squared minus 1, and that denominator stays the same. That just gives me x squared over x squared minus 1. Do a reciprocal and multiply, and I'm running out of room. And I'm going to rewrite, let's see, we have x squared minus 1 over x squared. And again, x squared minus 1 is x plus 1, x minus 1. We see my x minus 1's cancel. We also see that this x reduces with the squared of the x in the denominator. So I'm just left with x plus 1 over x.